Hello, I'm John Hammond with Indicate Technologies. Welcome and thank you for joining our webinar series, Digitize for Design and Inspection. Indicate Technologies is a leading supplier of equipment and services for both additive manufacturing and precision dimensional measurement to the high technology industries of the Western United States. Recently, we've seen exciting developments in 3D scanning technologies and related software tools. This video segment is one in a series of webinars designed to highlight just what is possible with these new tools. Each of the 20-minute segments will present a scanner and a software demonstrating a particular workflow to achieve a specific result related to either reverse engineering or inspection. We're trying to keep them short and very focused. This particular webinar segment includes digitizing the part with the Artec3D Space Spider. It's a handheld device, and reverse engineering it using Geomagic for SOLIDWORKS. The workflow will illustrate efficiencies in 3D scanning and CAD rendering that are unique to symmetrical geometries. In this case, we'll use a gear for a motorcycle drive belt. Before we get started, just a few quick points. When you logged in to the webinar, each of your audio lines was muted. In order to submit a question during the webinar, please use the Q&A button on your screen. We'll address as many of those questions that come in as possible at the end of the presentation. If we don't get to your question during the webinar, we'll follow up afterwards by email, possibly by phone call if you leave us your number. Each question will receive a response, and we'll make the frequently asked questions available to each of you. Again, thank you for joining us today. And now it's time to pass it on to Anton Bosniaga of Artec3D, who will introduce the scanner and scan the part. Anton, it's all yours.
Hello, I'm Anton with Artec3D here at Indicate Technologies, and today we're going to take a look at scanning and reverse engineering this symmetrical part using the Artec Space Spider and the Geomagic for SolidWorks plugin. So we'll capture this part using the Artec scanner and the software. We're going to transfer that file into SolidWorks using the Geomagic for SolidWorks plugin, and we're going to create a manufacturable CAD file out of that data. So let's take a look at the Artec scanner. This is the Artec Space Spider, blue light structured light 3D scanner. It has 4 cameras on it. It's a computer vision system. Unlike some of the other scanners in the industry, this doesn't use a CMM or some sort of an optical system for positioning, just uses these scanners and fancy computer vision algorithms. That is how it determines the position of the scanner next to the object and build a full model file that can be then transferred to SolidWorks for conversion into CAD. So let's take a look at the scanning process with the scanner. Here we have the Artec software, and we're going to start capturing this part. Now we deliberately chose this part because, as you can see, it is a black part and has some reflective portions to make it a little harder. And we're not going to capture the entire part, although we could flip this part over and capture the other side. So we're just capturing a quick view of this part. I could have probably done this a little bit quicker too, but this should be good enough. So there we go. We have a general overview of this data. We're going to take a look very quickly at how we would process this data here within the Artec software. So here is a preview of the file, and we could export this directly into the software, but it's always better if we process the data using the non-real-time algorithms. So we're going through a global registration step, which takes the data that we captured and tightens the alignment between the individual frames or the individual views of this data entirely on its own without any sort of assistance from us. We can also remove the base of of this part, so we don't have to deal with this extra surface within Geomagic for SOLIDWORks. And all we need to do now is create a file, an STL file or a mesh file from this part, which will be ready to be exported into Geomagic for SOLIDWORks. All right, I'll hand it over to Jeff to finish this part as soon as this process completes.
Thanks, Anton. Really quick, let's go ahead and import your part. Okay. Taking a look, it doesn't look too bad. Really quick, let's talk about the UI of Geomagic for SOLIDWORks. This is a left to right workflow. All of our tools are up here. This is a standalone plugin for SOLIDWORks, which allows you to bring in scan data or point cloud data and work with it directly in SOLIDWORks. We can do that by either importing, or we can connect to some sort of hardware and then scan in either points or mesh, and then do a little bit of mesh or point optimization, and then get that aligned to the global origin, and then take cross sections of that mesh or point clouds and work with it from there. It's really quick. I'm going to do just a little bit of cleanup beforehand. So I'm going to right click and edit this object. Then I'm going to change my selection tool to the lasso tool, and I'm going to make sure that I have select through on. And I'm just going to really quick delete out these kind of pigtails here. And same with this area here. Good. So our order of operation today is going to be, we're going to do probably a repair and maybe a smooth, because this looks a little bit bumpy. But then we'll apply some reference geometry to send it to the global origin using orient mesh, and then we'll take a cross section of it and then start reverse engineering from there. So I'm going to go ahead and go into repair, and I'm going to diagnose the mesh. And what this is going to do is it's going to take a look at the mesh and look for all of these issues here. So you can see that it's found some small components, small holes, and spiky vertices, and it shows up really nicely in red on your mesh. So I'll go ahead and say get rid of those. And then we'll probably smooth it at a 4% smoothness, nothing major. We'll just a little bit to get rid of all of these bumpy areas. So I'll select smooth. Oh, it's already at 4. I'll select OK. That looks pretty good. So now we can go ahead and apply the reference geometry to this part so we can move it to the global origin. There's a couple things that we need to do. I'm going to apply a reference axis in the middle of this piece here. I'll probably apply a plane on the top around this gear, and then maybe a symmetry plane in between one of the teeth here. So let's go ahead and get started with that. So we have a really cool selection method here, and that's Smart Select. It's over here. And all I have to do is left click and drag, and it highlights the area of similar curvature. And then it gives me a preview of what it's expecting. And I am happy with that, and I'll go ahead and say OK. Next, I'm going to apply a reference plane. So instead of using Smart Selection, this time I'm going to use General Selection, and I'm going to use the paintbrush method. So zoom in a little bit more. There we go. So I'm trying not to hit any curvature. I definitely don't want to hit anything that's not a plane. And I'm just getting a couple areas here. And maybe one over here. There we go. So then when I rotate to the side, I should see that that plane is right on that edge, and it is. So I'll go ahead and say OK. So at this point, I want to apply a point in the middle between this axis and this plane. And to do that, I need to go into SOLIDWORKS itself, because we don't have points currently. Well, it's a future release thing, but we don't currently have it. So I'll select the axis and the plane, and I'll say OK. And here we have a point right in the intersection of that axis and that plane. Now that I have that, I'm going to go ahead and put a symmetry plane. I'll go back into Geomagic for SOLIDWORKS, and I'll choose symmetry plane, and then I'll just try and find one of these tooths that goes right through the middle, and this looks like a good one here. So I'm going to zoom out just a little bit and then just draw a line. So what this is going to do is it's going to subdivide the mesh in half and then give me that symmetry plane between the two halves. Great. Now that I have all this done, I can go to Orient Mesh, and then I can choose the reference geometry accordingly. So my origin is going to be the point. My x-axis is going to be the symmetry plane. And then you can kind of see the global origin taking shape here, or where it's going to end up. And then my y-axis is going to be plane 1. And that's inverted, so I'm going to go ahead and hit this arrow so it's in the correct orientation, and I'll say OK. So now that it's sent that to the global origin, I can go ahead and remove all of my reference data, or my reference geometry rather, and then we can use our views and see that it's in the correct orientation. Perfect. Now we can begin to reverse engineer this part. So again, I'm going to use the cross section of this mesh, and I'll show you what that looks like right now. We have a couple different options in cross section. We can either use the cross section to make construction lines here, or we can just tell it to make to fit lines and arcs, or we can tell it to fit splines. So I'm going to choose the right plane, and if I zoom in here, we can see that it's giving me a black outline along the mesh. So this is exactly what I'm looking for. So I'll go ahead and I want to do a polyline because I want to make my own lines that are perfect instead of having to worry about the mesh being slightly imperfect. So I'll go ahead and say OK. And you can see, well, maybe you can't see, it's a little difficult, but I'll go ahead and hide that. And now you can see that I have a poly outline of the mesh. I can then go in and edit that, look at the plane, and then start to rebuild it from here. And really all that is just a bunch of sketching and whatnot. So this will take just a second. And basically I'm just going to make a couple boxes. I'll draw a line or two. Oh, that one was off. Perfect. That looks pretty good. I'll just drag this down here. Move this up to about there. So on and so forth till I've got my my fit how I want it. Okay, so that looks good. Let's go ahead and do some corner trims here. That looks good. I'll add a line here. Oh, let's see. Do another corner trim. Do one more corner trim here. Cool, and then I can apply any fillets that I want to in this part. So we can go ahead and just do a couple of them really quick. So, and we'll notice here that we don't have the end cap, but this side does. So we'll go ahead and create a construction line. We'll mirror that line to the other side. So we've got to draw a line real quick. Select my entity, select the mirror about, puts it over there, perfect. And I'll just take this piece and move it back. Cool, I'm done with the sketch. So then I can go ahead and revolve that sketch using the SOLIDWORKS tools. And I'll say OK. And then I'll turn on my mesh and take a look. And then from there on out, we can continue on adding in different features here and there. And we'll add in the teeth right now, and that should do for this demonstration. Because then it's just a matter of adding in circles and things of that nature, and that's all done in SOLIDWORKS. But this just shows you how well you can use mesh and point clouds in SOLIDWORKS instead of having to go outside. So I'm going to use the top plane, go back into Geomagic for SOLIDWORKS, take a cross section using my top plane, and I'm going to use this little arrow here, and I'm going to drag that top plane down just a bit so we can really get a sense of those teeth. And that was too much, so I'm going to pull that back up a little bit. There we go. I'll go ahead and say OK to that. And then again, hiding all these features, I now have that outline of the teeth. So I can take a look at this. If I remember where my right plane is, that's that piece there. So I'll go back into the sketch entities within SOLIDWORKS, create a new sketch, or I'm sorry, I'll edit this sketch, and then I'll recreate this piece here, and then I'll pattern that. Now that I have that done, I can go ahead and pattern that piece based off the center. So I will go in and select circular pattern. There we go. And then I'll put in, I think it's 27 instances. Nope, it's not. It's 32. Great. Now that I have that pattern, I can turn on my gear, turn on the solid body, exit that sketch, and then do an extrude cut with these profiles. Oop, I gotta select them. There we go. Extrude cut. I'll go in the opposite direction. I'll say OK. And that's how you reverse engineer. I'll go ahead and hand it back over to you guys. Thank you very much.
Thanks, Jeffrey. Now we'll get to some of the questions that came in. First one on our list here is, what training is available for Geomagic for SolidWorks? I think that one's to you, Jeffrey.
We offer 2-day training at our facility, either in Cary, Denver, or Moore Park, California, as well as 2-day on-site training at the customer site.
The next question is, when cutting the cross-section, what type of geometry is SolidWorks creating?
So that dotted line is a reference polyline. It's used for referencing the mesh, and then you have to put down your own sketches. But we also have the ability to put lines and arcs down automatically, or we can put splines down as well.
Okay. Let's see. Next, are there any automatic extrusion tools available in the plugin? I guess that they're referring to the Geomagic for SolidWorks plugin.
Yes, there are several automatic extrusion tools that make modeling a lot easier.
Okay, sticking with Geomagic questions, what is the auto surface command used for?
So the auto surface command is to basically put a dumb solid into SolidWorks. So we use this when we need to reference things, but we don't need to model them. Think of the bottom side of a car when you're wanting to pipe a new exhaust. You don't need to model the bottom of the car, but you just need to know where things are in space.
Well, this concludes the webinar in handheld scanning and reverse engineering within SolidWorks, hosted by Indicate Technologies. Please join us for the rest of the segments in the Digitize for Design and Inspection webinar series. And remember, producing high-quality parts at the lowest possible cost is your mission. Making solutions easy to deploy, manage, and scale is ours. Thank you for joining us, and have a great day.